Hey guys, sorry to keep you waiting several months. My name is William Britton, aka Kid Venicus, and today I want to talk to you about something that isn't near and dear to my heart, but a topic that is near and dear to my stress levels: physics. Now, hold on, before you click out, please listen up, because this is actually a class project that I'm making all fancy-smancy for you to keep you somewhat entertained. More specifically, I'm talking about Tumblr's favorite adopted demigod, Loki. Back! For those of you who haven't seen any Marvel Cinematic Universe films, these started all the way back in the ancient year of 2008 with Iron Man. The villain of the Avengers, Loki, is the aforementioned internet heartthrob that seemingly died at the end of Thor, but has been resurrected and is hell-bent on conquering Earth for Thanos, who we don't see until the end credits scene. In the final battle for New York, Loki is shot out of the air by Hawkeye, falls onto the patio of Stark Tower, and is hurled inside the building by the Hulk. Now, pause. This is all the context behind the scene. However, this isn't my project. My AP physics teacher, Mr. Minato, who is kind of like if you mashed together a hippie and a mad scientist, assigned us to create a final project of, well, whatever we wanted to do, as long as it had to do with physics. So, in all of my Marvel fanboy genius, I decided to cover this scene in particular. Unpause. Loki leaps up, starts shouting at the Hulk, claiming that he is a god, you dull creature, and I will not be bullied by and is swiftly pulled away and slammed into the concrete several times. This, my friends, is my project, calculating how many newtons of force were applied to Loki. Now, before we start getting into the nitty-gritty, let's get some base measurements down. Loki's height. Tom Hiddleston, as measured by Google, is 6'2", which is approximately 1.8796 meters. Since his boots don't seem to add anything, we're going to maintain his height at this. Loki's weight. Using Tom Hiddleston's height, we can now take a look at average body weights for someone at his height. A healthy weight for someone his height is about 170 pounds. His clothes seem to look like they could be about 30 pounds. Combined, this would be 200 pounds or 90.7 kilograms. Hulk's height. Now, this was a tricky one at first. However, I found this article on Wired.com by Rhett Allain, that estimated the Hulk's height according to each film he starred in. In 2012, aka The Avengers, Hulk is estimated to be at about 2.41 meters, bada bing, bada boom. Hulk's arm length. Looking at these images, I estimated that Long Arms McGee here has arms at about half his height, making his arm length about 1.205 meters. With these measurements, along with a clip of the attack, we can estimate how many newtons of force were applied to Loki in this sequence. Okay, one last measurement. When Hulk grabs Loki's leg, we lose a little bit of length in the overlay. I estimated Hulk's hand to be about 1 foot long, or 0.3048 meters, bringing our total radii to 2.7798 meters. Okay, here we go. Hulk slams Loki 5 times. 1, 2, 3, 4, and 5. Using a stopwatch, I found these slams to be, in order, 1.22 seconds, 0.72 seconds, 0.56 seconds, 0.36 seconds, and 0.62 seconds. I also had to find how long Loki's at rest during each of the slams. Considering that this clip is at about 30 frames per second, I went frame by frame in order to find how long Loki's body is touching the ground before stopping. In order:
3 frames or 1/10 of a second, 4 frames or 2/15 of a second, 7 frames or 7/30 of a second, 3 frames or 1/10 of a second, and 18 frames or 6/10 of a second.
Now for our equation. Since we are dealing with angular motion from wall to wall, our force equation is force equals mass times velocity on impact divided by time at rest. Now, in order to determine the velocity, we have the equation velocity on impact is equal to angular velocity at beginning, which is 0, plus angular acceleration times time of swing. In order to get the angular acceleration, we have to rearrange the equation theta equals initial theta, 0, plus angular velocity times time, which is 0, plus 1/2 angular acceleration times time of swing to the second power, to be angular acceleration 2 times theta divided by time of swing squared. Plugging this back into our initial angular velocity equation, we have 2 times theta divided by time squared. All of that multiplied by time, which gives us an equation of 2 theta divided by time. Following Okay, because we still have a bit to go. Velocity on impact, once we substitute equations, is angular velocity upon impact times radius, which gives us the equation 2 times theta times radius divided by time. Finally, plugging this into our final equation, we have force equals mass times 2 theta radius divided by time of swing times time of rest. Holy mother of Thor. Big thanks to Mr. Minato for helping me with this equation on several occasions, because otherwise these would be unbelievably wrong calculations. Okay, so taking these equations, we can plug in our values we determined earlier back into each other. The first swing comes to 12,984.97 newtons. The second swing comes to 16,501.73 newtons. The third swing comes to 6,735.40 newtons. The fourth equation comes to a staggering 36,670.51 newtons. The final swing comes to 4,758.51 newtons. In total, this comes out to 77,151.12 newtons of force. To put that into perspective, it would be like putting 7,715 pounds on you instantaneously. To put that into perspective, that's about the weight of 4 elephants. According to ScienceAlert.com, it takes approximately 2,300 newtons of force to break a human skull. This means that if Loki was human, he would have had his skull crushed on the first attack alone. The human femur can take 4,000 newtons of force. So if you stacked human Lokis on top of each other and broke all their femurs in one fell swoop, Hulk's attack would have decimated 19 of those and shattered another. Loki needs to see another doctor, preferably not Doctor Strange, because he would put him into a portal loop again. Thank you all so much for watching. Thank you again to Mr. Minato for giving us this amazing project opportunity, as well as for helping me with the equation calculations. The photos included in this are not my own. All links that I can find will be put in the description. Thank you so very much, and I'll talk to you guys soon.